Okay. Grab a calculator. Our problem says we have a $2,000 deposit, that's one lump sum payment, at an APR of 3% with daily compounding. And that's going to be for 5 years. They want to determine the accumulated balance. Okay, the $2,000 deposit is a lump sum payment. Doesn't say anything about making more payments. It says we're going to pay that all at once. That's money that we put in, so that's money that's going out. So that means our present value is negative $2,000. Then our interest rate is 3%. And we enter that as a percent. And then it says daily compounding. Daily compounding means every day, and there are 365 days in a year. So we're going to get 365 for P/Y and 365 for C/Y. And then N is going to be that 365 times the number of years. That's times 5 years. So that's how we're going to enter everything into the calculator for this problem. We're going to have a 0 for payments because we're not making any payments. And what we want to know is, of course, the future value. So we want to know FV. In other words, this is what we start out with, and then this is what we're going to end up with. We spend out $2,000, and then we're going to get back at the end some value at the end of the process. So all we do is go second, x to the negative 1 to get to the finance, choose 1 for the TVM solver. Our number of payments is 365 times the 5 years. Notice you didn't have to multiply that out before. You could do it right there on that screen. The interest rate was 3%. The present value was our $2,000 deposit. That's already in there, so I'll leave that where it is. We're making no payments. And we have 365 times a year and 365 times a year for this 365 days in a year. So we go back to the future value and we hit alpha, enter to solve. And at the end, the accumulated balance is $2,323.65. Okay? Any questions about how you pick out your information? The calculator is going to do all the math for you. You don't need to memorize formulas and stuff like that. All you're going to have to do is be sure you know what each one of those blocks, what number you're looking for to go in each one of those blocks on the calculator. Let's look at another one. We have $1,000 deposited. So that's a lump sum. Anytime it's a single deposit and not payments, that's going to be what you put in all at once and no payments. And since we're paying it out, that's going to be negative $10,000 with no payments. And it says the APR, 6.2%. So we put in 6.2. And then it says we're going to compound monthly. So that tells us we're going to compound 12 times a year. There's 12 months in a year. So that's part of N. That's not all of it, but it's part of it. It's how many times in 1 year they're going to pay you interest once a year because they compound once a year. So that's where the 12 goes in all those different places. And then it says for 5 years. So that tells us that for our number of payments, it's going to be 12 payments a year times 5 years. And that's going to equal 60 when we multiply it out. And again, the only thing we're not going to know is your accumulated balance. That's your future value. What will you have at the end? So we'll plug all of our numbers into the calculator. 12 times 5 at 6.2% interest with an initial sum of negative $1,000 and no payments. We don't know what the future value is. We are having 12 payments of interest and 12 compoundings per year. And notice if I don't even enter that last 12 in it, it changes it because it knows that PY and CY must be the same. That's always going to be the case. PY and CY are going to be the same value. So we're going to then go back to the future value. And it really doesn't even matter if there's something already in there, if there's a number in there. Once you go back and you put your cursor next to the future value and tell it to solve, alpha, enter, it changes what's there to the correct answer. So it says that the accumulated balance is $1,362.34.
What decimal was moved over in another place?
Yes, it would be, because I just realized I didn't put enough zeros in the present value. I just put 1,000. I missed my last zero. I wrote it down, but I didn't put it in the calculator. So yes, it'll be 13,623 and 37 cents. So you can see by my messing up there, the only thing really you can mess up, as long as you can put all your numbers in the right boxes, is not being careful to make sure that you've got the right entry, that you didn't leave out a zero or maybe misplace a decimal or something like that. So watch those things carefully. Okay? Now what that means is that even though you pay out $10,000, at the end, you gain $3,623.37. That was just in interest. That's putting your money to work for you. Now, this is the one that an example of the one that I know you had problems with. This one says determine the accumulated balance of a $2,000 deposit. So that tells us our present value. And since we're paying it out, or paying it into the account, that's going to be negative $2,000. And the interest rate on that account is 5%. And then the part that is different is where it says continuous compounding. So for continuous compounding, what you have to remember is there are 365 days in a year times 24 hours in a day times 60 hours in each minute, or 60 minutes in each hour. So that number that was in that table oops, and that wasn't supposed to be there, but anyway, I can change it. That actually turns out to be 525,600. And I will give you that table on your test. You can have that table copied on your note card on your test. That's not cheating. So that means that the number of compoundings per year is 525,600. And that's what's going to go down here for the payments per year and for the compoundings per year. So then the thing we don't know is going to be the future value. So N, based on the fact that we had 5 years, is going to be 5 times this 525,600. So we're going to go up and multiply N by 5. And it doesn't want me to do that. So that's what our screen looks like. Get that back to 5%. Ah, you hateful thing. So let me get everything filled in. And the only reason I put this in here that way is because that's how I could have actually figured it out. I could have figured it out right there and not had to go back to the other screen. So now I'm ready to find my future value, which is the accumulated balance. So we hit alpha solve and have 2568.05. So that's $2,568.05. Now, if you wanted to compare that to, let's say, annual compounding, the only thing you would change is you'd go up and say, well, I'm only going to compound 5 times once a year for annual compounding. And if I go back and resolve, let's see how much difference there is in the amount of money that we're going to get in interest. So alpha solve. And the difference is that if we do compounded yearly, n equals 5, c/y and p/y are both equal to 1, and that gives us a future value of 2552 and 56 cents. So if you compare these two, you think, well, compounding continuously, gosh, that must make a lot of difference. Did it really make that much difference? No. So compounding continuously is not really that big a deal. It sounds like it would be. And if you actually deposit a larger amount of money, it would, of course, be larger. But most of the time, the difference is not that much. Okay, we have one more example. And it says you want to accumulate $75,000 for your retirement. Okay? What is that $75,000? Is that what you have now? That's your future value. That's what you want to have when you're done. Okay? That's because when you retire, that's what you want at the end of the time period. So that's important. That word accumulate also implies that that's going to be at the end. And your retirement is going to be in 35 years. So part of your N, your number of payments, is going to be 35. And then it says you choose an account with a quarterly compounding. What's a quarter? That means 4 times a year. So P/Y is 4, C/Y is 4, and you multiply your N, your number of years, 35 times 4. And it says that you have an annual percentage rate of 5%. So our last question is kind of interesting. It says, how much of an investment does the plan require to reach your goal? In other words, what would you have to put in today? No payments. Put it all in today, right now. Well, you're going to get the 75 out at the end. So your question is, what is your present value? And remember, that's going to come out to be a negative number because your future value is positive. What you put in is money you pay out, and that's negative. It doesn't say anything about making payments. Your lump sum payment is going to be the only one. So we go to the solver. And we enter 35 times 4, which means you're going to actually have compounded 140 times. Four times a year for 35 years. Your interest rate is 5%. Your present value is what you don't know, so we'll leave it out. And for some reason, this one's being hateful about letting me leave out present value. If it doesn't want to let you leave something out, put a 0 in for it. And then your payment amount, that's going to be 0 because you're not making any payments. But what you want when you're finished is $75,000. And that's going to be for 5 years for C/Y and P/Y. So then we go back up to where the present value is, and alpha, excuse me? What? Oh, thank you. Yes, that would have been messed up. Then alpha solve, and it says that what you need to put in today, what you need to pay out, which is the negative, is $13,175 and 18 cents. Okay? Now, this is not part of this problem, but I'm going to ask you a question. How many of y'all think at any point in your life you're going to have $13,175.18 laying around that you don't need, that you're going to put in the bank and leave it alone and not touch it? Yeah. That'd be me too. Do you think anybody in here could not reach a goal of $75,000 for their retirement in 35 years if they were allowed to put the money in a little at a time? What if you could make monthly payments? So let's kind of redo this problem. The only thing that I'm going to change when I redo it is, rather than putting in a lump sum, I want to make payments. So that's going to leave my present value at 0 because I'm making no lump sum. And let's suppose that I'm going to make quarterly payments. Since the compounding is quarterly, I'd have to make quarterly payments. So 4 times a year, how much could I achieve this goal with if I only made 4 payments a year? And all I had to do was change the future value to 0 and then alpha solve on the payment amount. So if you could put in not quite $200 a quarter at the end of your 35 years, you'd have $75,000. So every 3 months could you put in $200? Now maybe, maybe not. But that's a lot more doable, isn't it? And in fact, we're going to look at some other problems where instead of paying quarterly, what if you just put aside a little bit each month? And we've looked at one of those already. So what we're looking at, now that I've talked about that, is an annuity, and I explained what that was in the video that I had you watch for the calculator. So just to recap, an annuity is a series of equal periodic payments. All the payments are going to have to be the same, and periodic means it's going to be a number of times per year. You're going to need to know that. You need to understand that your payments, as far as we're going to talk about, payments are going to be made at the end of the month. That's called an ordinary annuity. Okay? Most of the time, we make payments at the end of the month rather than make them at the beginning of each period. Now, the thing that's not being pointed out here is that an annuity is exactly the same thing as when you go to buy a house and you get a mortgage. It's exactly the same thing as when you go to buy a car and make car payments. The difference is that instead of you having a certain amount of money at the end, your debt goes to 0 at the end because you've paid off your mortgage or your car payment. But they work the same way. Now, if you were to make your payments at the beginning of each period, it's called an annuity due. And the truth of the matter is, you will actually get more money, more interest. If you make your payments at the beginning, because your first payment's going to earn interest because you deposited at the beginning of the month, and your last payment's going to gain interest because you deposited it at the beginning of the month. Whereas here, your ordinary annuity, your first payment's not going to get you any interest for that first month because you're paying it at the end, and your last payment's not getting you any interest because you pay it at the time you take the money out or the annuity matures. So you're going to get a little bit more money this way. But most common are the ordinary annuities. We probably won't have even any examples of this. But if we were to have one where it said that it was an annuity due, all you need to do is remember that you change that from end to beginning. That's the only difference. And of course, we always assume, as we've already said, that your payments and your compoundings are the same. So what we're going to be talking about in this section is depositing and investing, but in payments rather than in one lump sum. So that means that now your present value will be 0. And this is the one that I worked on, the video showing you how to use the calculator, so we're not going to work through that one again. But I'll work this one instead. So let's see what we've got here. At age 20, when you graduate, you start saving for retirement. If your investment plan pays an APR of 9%, and you want to have $2 million when you retire in 30 years, how much should you deposit a month? Now remember, you're starting at age 20, so you've got a long time. So you're going to retire in 30 years. How long is your money going to be put in the bank? 30 years. How often is it going to be compounded? Yeah, it says, and well, now let's see, an APR of 9%, but I'm going to deposit once a month. Okay? So once a month tells me that I'm going to make 12 payments per year, which is going to be compounded 12 times every time I make a payment, and N is going to be 30 years times 12. And that's going to turn out to be 360. And then my 9% is my interest rate. This time my present value is 0. I don't start out with a lump sum payment. I actually want to make payments. And the amount that I want to accumulate at the end of my 30-year period is $2 million. So my future value, because that's when I retire, is 2 with 1, 2, 3, 4, 5, 6 zeros. You'll have to watch on your calculator because you don't get to put commas in. So you've got to count your zeros carefully. So that's 2 and 6 zeros. And then we're going to solve for the payment amount. So here we go. We start out with N is equal to 30 times 12 at an interest rate of 9% annually, 0 present value. We're going to solve for the payment, but what we want to have is $2 million. And we're compounding monthly, so that's 12 months in each year. So alpha, enter, says your monthly payments, if you want to have $2 million, if you want to have $2 million when you retire in 30 years, your monthly payment is going to be $1,092.45.
Can you come look at my calculator since it has somebody to do? It'll let you put everything in, but it won't let me solve it.
Go back up to your payment. Press the green button. Can it have to be on?
Yeah, I don't know. I'm not gonna be right either.
Let's see what you're doing. Okay, these are at the end. It always is at the end unless they tell you that it's going to be at the end. So go ahead and hit enter there. But when you want to solve the payment, you're actually sitting on the payment and the out button and the enter button solves. Okay?
So you go down and hit in, but then you go back up to the
Right,
top.
go back up and what you want to know is it there to solve.
Okay.
Okay? Everybody else okay? Any other problems? Okay, this is the kind of problems that we're going to pretty much do for a while now. We've got a good arsenal of examples, so we're probably ready to move on. Let's see. savings plans, I think was, yeah, that was the first one, so I don't need that. So let's go on and talk about borrowing money, since that's something we're gonna do a lot of in our lifetime. It's the American dream, borrow money, have to pay it back.
Is that the next lesson?
Yes, this is lesson 3. And in case anybody's curious as to what TVM stands for, TVM stands for time value money. Because those are the 3 things that you're interested in using when you're trying to solve things. So in this particular lesson, this is lesson 3. We're going to be computing payments to pay off loans or credit cards or mortgages. So we're still paying, but we're not going to get the money at the end. We're going to get the house or the car instead. So that means that the present value is going to be the value of the loan, credit card, debt, or mortgage. What do you owe today? How much did you spend on it today that you haven't paid yet? So that means your present value is going to be a positive number, because it is cash inflow. They're actually, when you get that car loan, they give you a check to pay for your car. When you go buy your house, they pay for your house. So that's like transferring money through you. However briefly you get to hold it, like the 30 seconds it takes to take it to the deposit window. That's it. Your payment amounts, on the other hand, are going to be negative, because you're going to be paying those out every month. And the other thing that might seem a little bit odd to you is that your future value, the number at the end, it's going to be 0. And that's because you will have paid off your debt. You are no longer indebted. Okay, so you want that balance at the end to be 0 so that you've paid your debt before. So you're paying off debt. That's why it's 0. Now, just like before, we're going to use TVM solver for this, and we have to pick out our information. A student loan, that key word there is loan. That's money you're borrowing. Of $12,000. Is at a fixed APR of 18%. I'm sorry, 8%. And the time period is 10 years. So let's see what I know. I know that my present value is the amount of that loan. I know that I'm going to pay that loan off in 10 years. I know that my interest rate is 8%. I know that my future value of that loan is going to be 0 because I'm going to pay it off. This APR is the annual percentage rate. So that's the rate for a whole year. we're gonna make monthly payments. Payments once a month. So if we're gonna make monthly payments, we're gonna make payments 12 times a year, and they're gonna charge us interest 12 times a year. And 10 times 12 will give us the 120 payments that we're gonna need to make. That makes sense to everybody so far? Okay, so we want to calculate the payment. So that's where we're going to solve. We get our TVM solver, start at the top. We're going to go 10 years at 12 payments a year at an interest rate of 8%. The amount we're borrowing is our present value, so it's positive because we're briefly holding that money in our hand. We don't know what the payment amount is. That's what we're going to solve for. The future value is going to be 0 because we've paid off the debt, and we're making monthly payments, so that's going to be 12 and 12. We're going to make a payment at the end of each month, and we need to solve for the payment. So you put your cursor at payment and hit alpha and enter to get it to solve. And it says your payments are going to be $145.59. And then it says determine the total payment over the term of the loan. Now this one you do have to do the arithmetic. The total payment means that you're going to make payments of $145.59 once a month, or for 10 years, 12 times 10, you're going to do that 120 times. And we'll get the same answer either way. So we're going to repay $17,470. And 80 cents. Okay? The amount per payment times the number of payments. So in other words, we get part B by multiplying N times payment. To get our answer. Now the last part says, what percentage of the total payment goes to principal and how much of it went to interest? And that's kind of an interesting question. So what we have to do to figure that out is we take the $12,000 we originally borrowed, and if we wanted to find out how much of this was interest, then we would subtract our $12,000 from it. And when we do that, we would know how much, but this says what percentage, right? So the part that goes to principal is gonna be the 12,000 divided by total amount of payments. Which is the $14,559 and, I'm sorry, 17,000, looked at the wrong number. $17,470.80. So when we actually do that division, and since I've got that total payment amount right there, I should be able to type this in right without messing up. 12,000 divided by, and either use second and the negative sign will use that answer, or you can type in 12,000 divided by and then just copy that. And you get the same answer either way, so it doesn't matter which way you do it. And that gives us 0.6868. And because I want to convert that to a percentage, that's going to be 68.7%. Always round your percents to the nearest tenth. So 68.7% went to the principal. And then the rest of it was interest, so 1 minus 68.7, and that's actually 100. 100% minus 68.7% tells me that 31.3%. Was interest. Okay? So almost a third of what I paid in actually went to interest. Questions? Okay, let's do a mortgage. Says we have a home mortgage of $100,000. Your mortgage amount is your present value. It's the amount that passes through your checking account on its way to who you're buying the house from. So it's positive. Says the APR is 8.5%. And it says we're going to be making payments on this house for 15 years. At the end of this time, we will owe no more money because we will have paid off the house. And it says to calculate the monthly payments. And the fact that it's monthly tells us that we're going to make 12 payments a year. They're going to compound interest 12 times a year. And we're going to make 15 times 12 payments. So what we don't want to know is calculate the payment. So that's what we're going to solve for. So starting at the top, 15 times 12 means we're going to make 180 payments at 8.5% interest. We're borrowing $100,000. The payments is what we're solving for. The future value is going to be 0. Your payments per year is 12 and your compoundings per year is 12. So put your cursor where it says payment and then alpha, enter to solve, and it says your monthly payments and they're negative because you're paying it out. Your house payment is $984.74. And then to determine the total payment over the life of the loan, that's $984.74 times 180. And I've already actually calculated that out. It's $177,253.20. So that means you paid about $77,253.20 in interest. Okay? And again, on the last question, it says what percentage of your total output went to principal and what went to interest. So the percentage of the total payment that goes to the principal would be your $100,000. Divided by the total amount that you paid back, which is 0.5641. Or 56.4% goes to the principal. And then 100 minus 56.4 would be 43.6%. And that went to interest. Okay? Now, since we're coming close on time, I will record the last two examples. And in order to help you out, I'll go ahead and record for lesson 4. Please watch lesson 4 video that I put up there before we get here on Wednesday. And then we'll go quickly through lesson 4 and lesson 5. Lesson 5 and lesson 6 is about taxes. So everything in this whole unit is something you're going to have to deal with, regardless if you're going to be in business administration or what. You know, everybody has to pay taxes. Everybody has to buy a house at some point, or buy a car, or borrow money. And hopefully everybody saves for retirement. So y'all enjoy a nice 4th of July tomorrow. Have a good time. Cook out. Go watch the fireworks. And I will see you on Wednesday.